Hello guys, welcome to Jamb 400 series. Now in this class we are focused on physics and this is part 1. We are going all the way to part 40 now. We are showing you the latest trend of how the Jamb questions goes. And we'll be using one question to connect different questions. That's why this revision. We're using one question, hit multiple questions. I will use one question. As I give the explanation of one question, it gives you the question that revolve around that circle. That's how to revise. Hitting different areas and showing you these are the consistent questions and you need to take note of. We are going to be revising. Please follow me. Now listen to me. You are not cramming the question. What you are interested majorly is the explanation, because with the explanation you can connect many dots. Quickly, this is part 1. We're taking 10 questions here, but there are 10 questions, but then we are going to revise it more than 50 questions in this just 10 questions. Quickly, let's take the first question. The question says that the heat from the sun reaches us mainly by a process. Option A talk about radiation, B talk about convection, option C talk about conduction, and option D talk about reflection. Pause it and choose your own answer. Choose your answer in your mind before we reach out, before I explain anything. Have you gotten your answer? Of course, there are 3 ways in which it is transferred. We have by radiation, by convection, by conduction. I explained this when I got on with treating thermal physics, properly explained. So everybody, what becomes the answer? Of course, the answer becomes option A. Now, what is option A? Radiation. Now, I'm going to be giving you few statements, just simple statements to differentiate between the 3 of them: radiation, convection, and conduction. Now, the question is, what's radiation? Very simple. Taking that radiation is heat transfer from a source to a body without requiring any medium. Heat transfer from a source to a body without requiring any medium is called what? Radiation. And we'll talk about that. Is that what are the examples? Take note that charcoal burning and somebody standing there. Have you observed that anytime they are cooking or they are burning something and you are standing close, you're not even getting close to the fire, you are close to it, you start to feel the heat. That's radiation. Is the transfer of energy, of heat energy from that body, from the source to the body without requiring what? Any medium. Constant one which Jamb have asked is what? Heat from the sun, which is the one you just saw just now. Heat from the sun is an example of radiation. These are the 2 examples Jamb revolve around. So take note. Charcoal burning and a person is standing and people standing is what? Radiation. And heat from the sun is radiation. The second is what we call your what? Conduction. This is the transfer of heat from a source to a body by direct contact. You can see in this one there's no medium, but in conduction, direct what? Contact. Are you seeing that? And quickly, what are the examples by radiation? It occurs majorly in metals. Are you seeing that? Example of a metal spoon getting hot when placed in a what? In a hot pot. You are trying to cook and you carry your metal spoon and you place it inside the pot. Remember that the pot is hot. Heat is going to be transferred from the pot to the metal spoon. Are you seeing that? So, but there must be contact. There must be contact. There must be a medium. Do you understand? And the next one we call your word convection. This one is heat transfer of which this is interest of movement of what? Of fluid molecules, either of liquid or gas. What happened is that it occurs majorly when you are boiling water and so on. What happened? The molecules of water at the base acquire heat, and as they move to the top, the ones that are on top move to the base. It's just exchange, transfer of heat through the water, through the molecules of water, fluid. Now I give an example: boiling water, where hot water rises and the cooler water moves down to take the place of the water, of the hot water. The molecules, the water at the base, the molecules of the water at the base acquire heat and they move up. The one up move down. So that's just simply different between your radiation, conduction, and what? Convection. Don't forget that radiation, there is no medium. Of course, there's no medium. It does not require a medium. While conduction requires what? Medium. There must be contacts or there must be medium. While convection, there's transfer between all the molecules. Now, I also give you a mental picture to explain that. Look at it. This is radiation from the sun hitting us. You can see there is no medium here. The sun touches us. You know that the sun is far from me and you, very far. This is conduction. You can see there is contact between the source and the object, and you that you are going to receive it. Now look at the convection we explained. Take note that you can see that the warm air moves up while the colder air, the cool air moves down. That's what we call what? Convection. So convection occurs majorly in water when you boil water. This one occurs in metal. This occurs in what? In radiation and the sun and what? Do you understand? Quickly, let's take the next question. The question says momentum, electric potential, torque. The one me I call it torque, or you can call it torque, kinetic energy. The question is, which of the following combination is entirely consist of vectors? Now listen to me. Scalar and vector is a must. They must give you one example of scalar and vector. It's a must. You must see it. Remember that it is the according to the Jamb syllabus is the second topic. So you must see topic on what I've carefully taught everything about scalar and vector. I also gave a table. I'll show you the table here where we summarize them between scalar and what vector. The question says, which of these consists of vector? Of course, Now let's look at the diagram. What is this first one? This is momentum. What formula for momentum? Momentum is mass times velocity. Velocity is vector. So momentum is what? Is vector. So momentum is vector I. Now let's go to electric potential. Electric potential and EMF, they are scalar. Electric potential and EMF are scalar. Are you seeing that? Work energy and power is scalar. So this is scalar. This is vector. Now let's go to torque. Torque is the same thing as, don't forget that moment is the same thing as torque. Moment or torque, they are same thing. What's moment? Moment is force times distance. Force is vector. So moment, the torque where 2 is what? Is vector. What about electric kinetic energy? Kinetic energy is scalar. Take note that now constant past question, you know that this popular topic, work, energy and power, you know. Three of them, work, energy and power, are scalar. Electric potential, EMF, they are scalar. Do you understand? So the question is which of this is vector. So momentum is vector. Moment is what? Is vector. Do you understand? That's I and I. That's 1 and 3. Let's see option A. Option B 1 and 2. B said 1 and 3. C said 2 and 3. D said 1 and B. What becomes the answer? 1 and 3. That's option B. Becomes the answer. Do you understand? Now, please go. Now, look at it, everybody. Let me give you the summary of that table. Look at it. This is the table you should look at. Now, what to make you know that you understand this table? Under the note of this part one that I'm giving, I gave about 15 just on this that they have ever asked. So revise all the 15. Just go through it. Warm your brain on them. Warm your brain. Remember that this is revision. So the hotter you becomes, the burner you just the burning question. So you need to accumulate charges. Be charged. Are you seeing it? So mass is scalar. Weight and force is vector. Your displacement and length is your what? Scalar. Your distance and length and altitude. Take note, this altitude, constant past question is scalar. While displacement is what? Vector. Speed is scalar. Velocity is vector. Time is scalar. Acceleration is what? Is vector. Area and volume, scalar. Momentum, we just saw momentum. Momentum is what? Is vector. While temperature is scalar. Your moment and torque, they are what? They are vector. Pressure and density, scalar. Constant, electric field, constant past question. You know, we took electric field, especially when we're doing the electric field, talking about electric field, magnetic field, they are all what? They are vectors. So magnetic induction is vector, magnetic flow, stress. Are you seeing that? See, work, energy and power. Work, energy and power, they are scalar. Electric charge and electric current, they are scalar. Electric potential and EMF, I told you just now that they are scalar. Your resistance, your capacitance, your inductors are scalar. Reactance and impedance, they are scalar. Your mechanical advantage, velocity ratio, and efficiency, they are all what? They are all scalar. Please, I told you there are 15 questions I've dropped in the note of this. You also practice them in the CBT. If you get the 15, that means you have understood everything about scalar and what's vector. Let's see another question again. Look at the question. Which of the following quantities is what is scalar? If you miss this one, I will blow you. Option A, displacement. B, weight. C, mass. And D, tension. Fast. What's the answer? Of course, it cannot be displacement. Displacement is a vector. It is distance in a specified direction. Weight is the same thing as force. Or weight is a type of force because they are Newton. So it's a vector. Now look at tension. Tension is a type of force. Force is what? Vector. So it's a vector. Mass, we just saw that mass is scalar, right? I think you revise that table. Very important. Option C becomes the word answer. Quickly, let's move. We're giving a diagram first. Let's see what the question is saying. All eyes on the diagram. The question says that the diagram above shows the velocity time graph. The statement that is true about the motion is, everybody, before analyzing the statement, let's interpret the graph. What can you see between E and F? What can you see between E and F? The body accelerates between E and F, this acceleration, right? Now, but take note that it's not starting from the 0 mark. Are you seeing that it's not starting from the origin? It accelerates, but it's not starting from the 0. What do you see between F and G? That's uniform. The movement is what is uniform. We can say uniform velocity or uniform speed. Are you seeing that? Now, what can you see between G and H? It is what? Decelerating. It is decelerating. So let's say deceleration. So E to F, it is accelerating. F to G, it is uniform. The motion there was uniform. And if you are coming down, it is what? Decelerating. Let's see the option. Let's see. Option A say has no acceleration between F and G. F and G. Is there accelerating? What can you say F and G? F and G, it is what? Uniform. It is neither accelerating nor what? Decelerating. So option A first. Let's see option B. Decelerating between F and H. No, it is uniform here and decelerates. So B is wrong. And you see that. Let's see option C. Has a constant speed between E and F. E and F. No, it's accelerating. Does not have a constant speed. So C is wrong. Option D say accelerates. at F and G. F and G, it is uniform, so it is wrong. You see, what becomes the answer? Of course, option A becomes the answer. No acceleration between F and what? And G. Do you understand that? Quickly, if you say you understand that, let's hit the next question. The question says that a particle slows down from a velocity of 10 meters per second at 2 meters per second to come to rest after 4 seconds. The displacement of the particle in the last second. Please, this statement. Now, if you have been following my motion class, I told you how to differentiate between. That's why revision is very important, because in revision we connect the dot. I told you how to, when they ask you last seconds, in last seconds they are trying to say what's the time? The time is 4. So the last second is like different between the 4th second and the 3rd second. Are you seeing that? If they say 10 seconds, that's between 10 and 9. The distance between them. Are you seeing that? Let's see the questions we're giving option A, B, C. Now, let's bring out our parameters. So, so that a particle slows down. Of course, I've told you times and number. Anytime you hear slows down or brake is applied, it means that the body is decelerating. So, acceleration will be what? Negative. It will be negative. So, we don't know what it is. And final velocity will be what? 0. So, anytime you hear that brake is applied, are you seeing that? Or a body comes to rest, or a body slows down. 3 statements. Anytime brake is applied, or a body comes, hope you know that when brakes apply, the body will come to rest. Or a body slows down. For a body to slow down, if this brake is applied, 3 of them are connecting. Acceleration will be negative, but final velocity will be 0. But when you hear that a body starts from rest, U will be equal to 0. That's initial velocity will be equal to 0. But when a body comes to rest or slow down or brake is applied, final velocity is equal to what? 0. So we're told that a particle slows down with a velocity. So that means that velocity is the initial velocity. U is given as 10 meters per second. Acceleration, that means we told you acceleration will be negative. That's minus 2 meters per second. And we're given the time to be equal to what? 4 seconds. They say, what is the displacement? That's the distance. In the last second. So for us to get the distance simply, we're going to get the distance of the 4th seconds, get the distance of the 3rd second. So I can practically say x will be equal to S4 minus X3. So let's get distance. So that we're going to use distance is equal to what formula? We have U, we have T, we have, so that's, we're going to use UT plus half AT squared. You know this formula and equation of motion. For me now, for the fourth one, what will be the distance? Distance will be equal to, what's U? That's 10 times T, what's T? 4 times 1 over 2 times what's acceleration? Minus 2 times what's the time there? 4, that's 4 squared. Do that. 10 times 4, that will give us 40 minus these 2, we cancel this minus 2, that's 16. What's 40 minus 16? That will give us 24. So this distance, the distance at the 4 is equal to 24. Let's do for 3. That will give us 10 following this formula. This formula is what we are going to follow. So 10 times 3 plus 1 over 2 times minus 2. Cancellation is minus 2. What's the time there? Times 3 squared. That will give us 30 minus this. Will cancel this. That will give us 30 minus 9. Is that correct? What's 30 minus 9? That will give us what? 21. So the distance will now be equal to 24 minus 21, which is equal to 3 meters. Option A become the answer. Do you understand? You can pause it and take it over. The main thing that taking that when you hear brake is applied or it slows down or it comes to rest, taking that final velocity is equal to 0. Final velocity is equal to 0, acceleration will be negative. That means the body is not accelerated, it's what? Decelerating. Quickly, let's take the next question. The next question says, hold on a bit very quickly. This class you're watching right now is just one out of a series of classes within the LearnLift app. And guess what? LearnLift is a mobile app, right, where you study intensively as well as extensively. So within the LearnLift app, you can see it very quickly. You have access to all your subjects there. You have your use of English, you have your mathematics, you have your physics, you have your chemistry, you have your biology, you have your Jamb 400. All of them, they are different subjects within the LearnLift app. And of course, you have different topics under every particular subject, and everything has been narrowed down to you, down to the curriculum, with their past questions and everything to the core. And don't forget that within the LearnLift app, you have access to your video lessons where you can start going through your classes uninterrupted. You have access to your notes. Oh yes, your notes well organized, well structured for you, and you are running through all of them. And of course, inside the notes are past questions for you. You have access to your past questions in CBT format, where you can go through all of them extensively well. All of it within the LearnLift app for you and more. And guess what? Very important. You want to download the LearnLift app, all you need to just do is head down to Play Store or your App Store and type LearnLift. That's all. Once you type LearnLift, of course, the app is going to pop up for you and you're going to see the logo, and then you download the app and then you follow up on your studies intensively. Before we proceed, let's get back to class. Flow with me. Next question says that we're given that determine the acceleration in meter per second between 2 points in a velocity time graph. Okay, of the coordinate 15 and 5, we're given the option. Very simple. It's a graph, so let's plot that graph. This will be velocity and this will be time, right? The question says between 2 points. This is 5 seconds, and so that means this is 5 seconds. And what is the other time? 15 here. That here is what? 15. So here was what? Here, when it was 5, here is what? Is 10. And when it was 15, this place is 25. So we can do it like this and do it like this. If you plot that graph, it's a straight line graph. So this is practically acceleration. Here is the slope. Hope you know the acceleration here. If you watch my class, I told you that in velocity time graph, acceleration is the slope. Because what is acceleration? Acceleration is given as velocity over time. And from here now, what is slope? The slope here, what is slope? Slope normally is given as what? It will be v2 minus v1 all over t2 minus t1. So that's slope. So acceleration will be equal to slope in the velocity time graph. So from here now, that will be equals 25. v2 minus what is v1? That's 10. All over, that will give us 15 minus 5. Now, these questions are cheap. This will give us 25. Sorry, that will give us 15 all over 10. And if you check here very well, this will give us what? 1.45. And 1.5 is your what? Option B. Very simple. Quickly, let's take the next question if you say you understand that. The question was given that a ball P was shown in the diagram in a state of, the ball P shown in the diagram above is in a state of, option A says stable equilibrium, B says neutral equilibrium, C says unstable equilibrium, D says dynamic equilibrium. Quickly, everybody, what become your answer? Choose your answer first. First, I'll start to tell you that there are 3 equilibrium positions. We have stable, we have neutral, we have unstable. What is, have you chosen your answer? Before I can go now. Now, what is stable equilibrium? Stable equilibrium, if you move the body from where it is, you move the body will return to that same particular spot. That's stable equilibrium. Are you seeing that? That's what stable equilibrium. Now, if you move this body from this point, with the body, what happens? The body will move and come back to that point. That equilibrium is stable. It is not neutral. It is not unstable. The answer becomes what? Option A, which is your what? Stable. Now, let me explain the difference between 3 of them. Look at it, everybody. All eyes on the diagram. Now, what can you see? This is a stable equilibrium. This is unstable equilibrium. This is neutral. In stable equilibrium, if the ball is displaced, it will return to the original position. That point it was, if you displace it, it will come there. That's what we call stable. Unstable, if the ball is displaced, it will accelerate from away from that equilibrium point. That means if you displace this ball, it will move either away to this point. It will move away from this center point. So anytime you displace it, it will not return to that difference between stable and stable. If you displace it, it will return to that center point. But in unstable, if you displace it, it will move away from that equilibrium, that center point. What of neutral? If you move it, if you displace it, it will come to a new point. It will stay in a new location. So do you understand the difference between stable, unstable, and what? Equilibrium. I'll give you another diagram to work on your mindset. Look at this diagram. Are you seeing that? You can see that we have the stable, we have the unstable, and we have the neutral. Why am I showing you all this? They are constant past question. If you feel anyone, I will look for you. Are you seeing that? If you say you understand that, quickly, let's take the next past question. The question says that the center of gravity of a uniform meter rule is, in option. Everybody, what's the length of a meter rule? Length of a meter rule is what? 100 centimeter, or you say it is 1 meter. 100 centimeter or 1 meter. 100 centimeter, or you say what? 1 meter. Everybody, what's the length of a meter rule? 100 centimeter, or you say 1 meter. And then I'll say, what's the center? Of course, if it's 100 centimeter, the center will be 50 centimeter. But if it's 1 meter, the center will be what? 0.5. Let's say I'm going to show you mental diagram. Option A say 100 mark. This is 99.9. C says 50 centimeter mark. This says 0. Of course, the center is called the what? The 50 centimeter mark. 50 centimeter, 50 in centimeter, 0.5 in what? In meter, making option C to become the answer. Look at the diagram. You can see the center mark. What's the center mark there? That's 50. So from here to here is 0. From this is 0 to 50, from 50 to 100. That's a standard meter rule. Are you with me, everybody? Let's see question 9. The question 9 is constituent of the liquid. Type of containing vessels. Option I said density of the liquid. IV say acceleration of gravity. The question say, let's see what the question. Which of these will affect the pressure of a liquid? First of all, let me tell you, as a physicist, when they ask which of these will affect, the first thing to do is to bring the formula. What's the formula for pressure? What formula for pressure? Pressure is given as density times height times acceleration due to gravity. This is density. We call it rho. So let me write it again. Pressure is equal to rho hg. This is density. So pressure depends on one, density. It depends on the height. It depends on what? On gravity. So let's look at the option. Because option I said constituent of the liquid. B said the type of vessel. Very funny. D said the density. Yes, it depends on density. Because look at it. This is density. It depends on acceleration to gravity. Look at it. This acceleration due to gravity. So first of all, let's see whether the options are picking 3 or 2. The question says which of these factors will affect? Option A saying 1 and 2, B said 2 and 3, C said 1 and 2. That means they're picking 2. So which 2? That means 3 and IV. 3 and IV, making option D to become the right answer. Are you seeing it? Everybody, what does pressure depend on? Formula for pressure now. P is equal to what? P is equal to density times height times what? Do you understand that? Quickly, the last question for this, which is going to touch on that question. One question touching many questions. The question is that 4 degrees Celsius, the density of a fixed mass of water is that. I've heard of what we call anomalous expansion of water. So I explained that because I'm still going to stress it here though. But everybody, if you understand it, pick this question, pick the answer. At 4 degrees Celsius, the density of a fixed mass of water, what happened at 4 degrees Celsius? A said to be same, B said maximum, C said minimum, D said C. Fast. Everybody, when does water misbehave? That's what we call the anomalous expansion of water. Water misbehave between 0 to 4. At 0 to 4, what happens? We said that what the density will increase. If density, it increased to what? From 0 to 4. At 4, the density is maximum. And if because the density is maximum, the volume will be minimum. And because the volume is minimum, at that point, water contracts instead of what? Expanding. So they say at 4 degrees Celsius, what will happen to the mass? At the density of water, what will be maximized? It will be what? Maximum. Because from that point, it will no longer contract. It will now start to expand. I'm going to explain that, making option B to become the answer. I know some of you may not be clear, some of you that don't understand this thing very well. Let's go. Let me explain that deep down. Everybody look at this anomalous expansion of water. Let me explain. Now take note that as the temperature of liquid increases, their volume increase. As temperature increases, volume increase. Therefore, they tend to expand. But water has a funny behavior. That is called the what? Anomalous expansion of water. What's the anomalous expansion of water? Now look at it, everybody. Focus on this. Now, before 0, let's say the water starts and we are trying to increase the temperature. Before it gets to 0, what happened? From before 0 degree, the density of water decreases. Therefore, water tends to expand. Why is there water tends to expand? Everybody, what's density? Density is mass all over volume. It means that if the density is decreasing, what will happen to volume? Volume will increase. And if volume is increasing, that's expansion. If you are increasing the volume, you are expanding. This is what happens before 0 degree. Before 0 degree, density of water decreases. Therefore, their volume increases. Therefore, water tends to expand. But when they get between 0 degree to 4 degree, what happens? Density starts to increase. So density will increase. Everybody, if density is increased, what happens to volume? Volume will reduce. Because volume will decrease. Because volume is decreasing, it is not expanding. What do we say? We said it is what? Contracting. Are you seeing that? So that is what we call what? Contraction. So between 0 degree to 4 degree, what happens? Contraction occur. Because it is at that point, from 0 to 4 degree, that's when density will stop decreasing and start to what? Increasing. The highest point is going to get is when you get to what? To 4. That's why we say that at 4 degree, what will happen? Density is going to what? Increase. That's the maximum increase of density. Because it starts to increase from 0. It will stop at what? At 4 degrees. Are you seeing that? Volume will be decreased. So at that point, we call it what? Contraction. Immediately it past 4 degree, what will happen? Between 4 degree to 100 degree, what happened? The volume will return back to the way it is. It will start to what? The density will start to what? To decrease. It will, density will fall. If density will fall, what will happen? This is expansion. Are you seeing that? Because if density decrease, volume will increase. So this point is what we call your what? Expansion. So water misbehave. At this point, it is expansion. At this point, it is expansion. Before 0 degree, it is expansion. After 4 degree, it is expansion. This point where it misbehave is called the anomalous what? Expansion. So at 0 to 4 degree, what happens? Density increases. Because density will increase, volume will what? Will decrease. And because density is increasing, volume is decreasing, we call that what? Contraction. Normally, water is supposed to be expanding. At that point, it is what? It is contracting. Quickly, if you say you understand this, let me summarize this. I'll summarize this by telling you that water contracts between 0 to 4 degree. I explained it just now, and we said that it is maximum. The density will, that means it will keep contracting until meeting a maximum of what? Of 4 degree. And at that point, you said that density is said to be what? Maximum. And we now went further to say that it now starts to expand between what? 4 to what? To 100 degree. And we said, take note that 4 degree, it has a maximum density and it has a minimum volume. From the explanation I gave just now, if density is increasing, volume will what? Decreasing. Do you understand? So this is the summary of anomalous expansion of water. If you say you understand it, let's use it to catch 5 questions. Remember, we are done by seeing the 10, but I want to use this statement now to catch 5 questions very fast. Everybody look at it. Similar questions under that anomalous expansion of water. Jamb 1979 question 9. In the range of temperature, in what range of temperature is the expansion of water abnormal? That's anomalous. A, 280 to 2112. B said 80 to -76. C said 40 to 0 degree. D said 96 to, and E said 0 degree to +4. Everybody, what's the answer? Fast. What's the answer? The answer becomes what? Everybody should get this option. E becomes the answer. We said at 0 degree to what? To 4 degree, water is said to undergo what? Abnormality. Because at that point, the density is said to increase and volume will decrease. Instead of water to expand, it's said to what? To contract. Do you understand? And next question, similar question on that nature. If you miss them, Jamb 1985 question 18. Water shows abnormalous behavior at what? A, below 0 degree, between 0 to 4. C said at exact 42. D said 40. What becomes your answer? When does it show anomalous? Option what? Option B. Do you say above? What becomes the answer? Option B becomes the answer between 0 to what? Quickly now, let's take number 3. The question says that Jamb 2009 question 19. At 4 degrees Celsius, the volume of a fixed mass of water. What happened at 4 degrees Celsius? Option A say the volume. They are talking that they are not in that question. They ask density. This one now they are referring to volume. At 4 degrees Celsius, what happened to the volume? First of all, will it increase or decrease? At 4 degrees, density is maximum. What happened to volume? Volume you want minimum. A is a minimum, C is a maximum, D 0. What becomes the answer, everybody? The answer becomes your minimum. Making option B to become the answer. Let's just we are taking 2 more questions and we are done. Jamb 2004 question 33. When left in a freezer, a bottle full of water cracks on the freezing into ice. This is because a decrease in volume, contraction of the bottle, expansion of the bottle, the increase in volume of water. They say that when you put water in the freezer, water is going to crack. Why? We said, what becomes the answer? First, look at pause it and tell me your answer. No time. What is going to happen? Normally, we say water, as the temperature increases, water tends to expand. The only misbehavior is between 0 to 4. Right? Aside 0 to 4, what happens? It keeps on what? It keeps on expanding. So the water is going to the bottle is going to crack because the volume of the water is increasing because density is what is decreased. Well, which of them show that? Option A said decrease in volume. No, not the decrease in volume of water. Contraction. No, the bottle is not contracting. Expansion in the bottle. No, it's not the bottle that is expanding. It is the water. It is the volume or it's the water. So it's an increase in volume of water. Yes, the water tend to increase because we say from 4 degree to 100 degree, there's increase. All right, if there's decreased density, increased volume, and which is called what? Contraction, making option D to become the answer. Quickly, let's take the last question, which is number 5. As I wrap up this part, Jamb 2000 question 25. The question says the quantity of water at 0 degrees Celsius is heated to about 30 degrees Celsius. At each degree rise in temperature, what will happen to the density? Do you understand? The temperature increases from 0 to 30 degrees. At each degree rise, what will happen to what? To temperature? A say rise steadily, B say rise and then fall, C said fall steadily, D say rise, fall and then rise. Who can tell me what becomes the answer? Very simple. Now look at it. Let's see what happened. At before 0 degree, what happened? The density is going to what? To decrease. density will decrease. Now, between 0 to 4, what up to density? Density will what? Will increase. Between 4 to 100, what up to density? Density will decrease. So at this point, density is decreasing. At this point, density will increase. At this point, what can you see? The density will what? Option A say will rise steadily. No, rise and then fall. Yes, because it's decrease here, increase, decrease. So it is rise, then fall, right? B. C said fall steadily. D said fall and then rise. Now look at it. What happened from after 0 degree? What happened from 0 degree? It went up, it rise and fall. So that's rise and fall, making option B to become the answer. This one would have been the answer. I wish they say before 0 degree is going to fall, rise and fall. But they say start from 0. What happened from 0 degree? It will rise, fall. So rise and fall, making option B to become the answer. Do you understand that? That's everything about part 1. Please, I'll see you in part 2. Remember, this is the 400 series. I'll see you in part 2. But for now, peace out. Go through the notes. The notes is very important because you're going to see all these things I said and practice the CBT. The CBT dedicated for only this part 1. So ensure you get all. I'll see you in part 2, but for now, this class you just finished watching, of course, is brought to you by what? By the LearnLift app. Oh yes, and within the LearnLift app, you have access to all your classes from the beginning to the end. Everything is well organized for you. Every singular subject, every singular topic, followed in line directly with your syllabus and your curriculum. And of course, can I tell you something lovely about the LearnLift app? Oh, this is the sweet part of it. You have access to your Jamb classes within the LearnLift app. You have access to your WAEC, your NECO, your GC classes. You have access to your post-UTME classes. And that's not all. Of course, for your secondary school, you have access to your secondary school classes, whether SS1, SS2, SS3. You have access to your classes directly. And of course, if you're in the university, you have access to your 100 level as well as 200 level classes, all within the LearnLift app. And of course, your 200 level classes are for medical students. All of them are there, well structured and highly organized for you. But please, before you proceed, just head down to your Play Store or your App Store and just type what? LearnLift. Immediately you type LearnLift, of course, the app is going to pop up for you and you download the app and then you start learning immediately. And also very quickly, all you're going to do is that in the description of this video or in the comment section, just open it. You see the link to our WhatsApp channel. Click on it and you are in the WhatsApp channel already, where I'm going to be dropping information every blessed day on a regular basis. And also very important, if you want to reach out to LearnLift, this is LearnLift contact, any of the two, right? Just copy it down and then WhatsApp us, right? Either you send WhatsApp message or you put a call across to us and all of that, and we're going to attend to you immediately. Guess what? I'll see you in the next chapter. For the now, peace out. Bye.